Hello, this is Yannis from Any Repair. Today we will go through another MacBook a2141 that came to our lab dead. Let's go and see how we'll deal with this damage. That is the MacBook, which is wounded. We're plugging the charger, and you can see that it is receiving 5 volts and 200 milliamps. The first Type-C port. In the other one, I'm trying to plug it. I finally plugged it, and it's the same behavior, 5 volts and 200 milliamps. Let's go and check. I'm wiggling a bit to see if something will change, but nothing. Let's try to check the other ports. The third one, same behavior, 5 volts, 200 milliamps and nothing. And let's go and check for voltage in the main rail. We are having 12 volts, no short, as you can see. The 12.32 is not the proper voltage, but it's okay. Let's check for the LDO, which is 3.3, which is good because no LDO, maybe no CPU for us. So I have checked this power management IC, and while I am plugging the charger, we will go to the microscope view and check this. You can see that the PMIC is a little bit blasted or something. You can see let me focus a bit better. You can see that it is having something spoiled, something broken on it. Maybe a short, maybe something did that. And this PMIC is having this damage, but it's producing the voltages. Not all of them, but it's doing its work. But I think we must change this and check. You can see we are having the 0.9 volts and 0.1, 1.1, I'm sorry. And this coil is okay. And everything is okay, but the T2 chip is not receiving the proper voltages in order to work properly and power on the device. So we must go and remove this PMIC and use another one from a donor board, and then check it on the board if the board is cured and we are having something better. So, adding flux and using our heat gun in 400 Celsius with 50% airspeed. And we are trying to heat up the PMIC. I'm not using a proper tweezer. It is not fine. It is not fine at all. It is curved from a lot of jobs that I have done. and you will see that when removing it, it will drop. And I'm not changing the tweezer. You see, I am lazy, and I'm trying to work in a different angle, reheat the chip, and lift it with not the proper tweezer. And it's off again, and it's off again. Oh God, mercy me. I am lazy, okay, I'm lazy. But the PMIC is removed. We have poked a lot of things beneath it, but we are okay, we will fix them. So let's go. We will work in high speed. We're trying to fix this resistor that we have poked and misplaced it. We're trying to put this back on. We're adding some flux, and we're trying to do properly what we have done before. While we were lazy to work, and now we're not lazy to work more. I think that's the price for being lazy. And now we will clean up the old solder. We will add some leaded in order to make things easier for cleaning the pads. We are doing so, and we are careful not to poke again something and remove it from its place, because we will need it. And now with our wick, we will clean the pads to be nice and flat. We're not pushing too hard in order not to scrape the UV mask from the board. This is okay too, I think. Reflowing the capacitor, cleaning a bit. It's easier now, it is already hot. And now I think it's time to remove this IC from donor board. The IC is this. We have already removed from the donor board, and now we will try to clean it up and reball it. We are not pressing the soldering iron on the chip because it's very easy to destroy the UV mask that is securing the pads and the traces, and that will be very hard to isolate with UV mask. So we're very extremely careful when we're using the wick on the bottom of the chip in order to clean up the pads. And now it's time for us to add some paste, soldering paste. We will add the soldering paste with our knife, with our razor, and we will scrap it in order to fill in all the holes And we are using our razor. The soldering paste is a bit dry. That's good. If it's wet, we must dry it with a paper. That's what I have done. We're trying to make all the holes full and not leave any excess soldering paste on the holes, because it will melt and bridge. So we are scraping and scraping, and when we are sure that we have done the job right, we will clean up a bit with isopropylic and a cotton pad or whatever you like, or whatever you have. And after that, we will heat up the direct stencil in order to make the soldering balls for the chip to be soldered on the board. I will try to remove the chip now and check the balls if they are even, the same size, if we have any bridge. But the chip doesn't want to be removed, so I will add some flux and reheat. And I will be very confident that the chip will slip off the stencil and sit on my towel beneath, or I will ruin the balls and redo the job again. But I was lucky. I'm cleaning up the IC to see what we have done, we have accomplished. I think it's good. I think it's good. Some dirt on it will be removed, but the balls are right. And after a good cleanup, it will be usable. And if the PMIC from the donor board works fine, I think that it will work too. It will work on the board, and the board will be good to go. Nice cleanup with a toothbrush. Electric toothbrush is very good because we don't need to move our hands and we can focus on the spot we want to clean. So after that, we will go on the board. This is it. You can see that we are having a hole, a pad removed, but this pad is no connect, believe me. I have seen it on the board view. I'm using my finger. We can use a brush better. I'm having a brush, but it's somewhere I cannot find it right now. The finger is a good solution. I'm trying to align, and after the alignment, I will heat up the chip. It's not so easy because there are no borders printed on the board. So we're trying to align the chip with the space between the capacitors around it. And now we can heat up the IC in order for the solder balls to melt and make contact on the clean pads beneath and solder the IC properly. The temperature is the same from the desoldering, 450% airspeed. And as we have heated the IC properly, we're trying to poke it in order to see if it is moving a bit. If it is hovering while we're poking it, I'm checking the capacitors nearby if they are in a liquid state. If they are in liquid state, it means that the IC is in the same state too. So I will poke when the capacitor nearby is moved, like that. And I think that we are good now. I think we are okay, but I'm ensuring that will remain hot and try to poke it from other angles. Okay, I think we're done. We'll add some flux and reflow. Because the hovering has not been exceeded. Now the airspeed is bigger. Is higher, is the proper word. And now with the help of the flux, we are reflowing and reflowing. I'm leaving it to sit because I'm not editing, because it's very critical for the chip to be soldered properly. And poking it and dancing with the air is the proper test to check if the pads are soldered. Now we're done. And now we will clean up a bit and let the IC to be cold in order to check for the board if it's alive or not. The isopropylic alcohol is always a help for cooling things around. And I think we are ready to test. I have put the board on the chassis. I have plugged the screen and the Type-C connectors. That's all we need to check if we're having a healthy board, an alive board, and now I will plug the charger. And we have a good negotiation. We have 20 volts and its consumption is good. I must raise the keyboard, and we have an Apple. Yes, we are good. We are having an Apple. It will boot up. That's good news. And after that, I think we're done. The job is finished. That was the repair as you saw. If you like this video, consider like, subscribe and share. Thanks for watching. See you in another repair. Bye.